Hello there guys, welcome back to another epic inexorable maths video. In this video, we're looking at higher order moments and how to find them, okay? So, what is a moment? I said it in the last video, link in the description to the previous one, that's where this all kind of begins. But what is a higher order moment? Well, a moment in general is just the expected value of x to the power of some normally natural number. So x to the 1, the expected value of x to the 1, which is this here, this is called just the expected value. It represents the mean, the theoretical mean of a random variable. This is the first order moment because it's x to the 1. What I've written here, this is new. This is the second moment or the second order moment of the random variable x. It's the expected value of x squared. Now you might say, what can you do with this? This is the mean. What's this? Well, it's kind of related to the standard deviation and the variance, but also it has lots of other uses as well. So it's just one part of the anatomy of a random variable. It gives us information about a random variable. This is the formula. You can see it's the exact same, just with a different, with an x squared there. And I'm going to make the point, because we will do this very briefly, but in general, the expected value of x to the n, again, typically we're talking about n being a natural number, so 1, 2, 3, 4, 5, etc. But it can be fractions in some cases, although that's very rare. This is the sum of just the x to the n's over the probability that x equals x, okay? So that's, it just naturally, very intuitively kind of follows. But let's actually do a question and see how to actually find this, because it might not be that obvious just by looking at this. So let's do a question. Okay guys, so a random variable has probability distribution there. Find the expected value of x and the expected value of x squared. Okay, so first of all, let's start by finding the expected value of x using what we have already done a few times already, and of course just using that top formula there. So what this is saying is the probability that this random variable, whatever real life situation you want to imagine that it represents, the probability that it takes the value 1 is 12 out of 25. The probability that it takes the value 2 is 6 out of 25, etc. What's the value that it's going to take on average? Okay, so just using the formula, we're going to multiply the columns, multiply the column, each component of it, and then add them all up. That's what I meant to say. So 1 times 12 over 25. Okay, 1 times 12 over 25, so just 12 over 25, plus 2 times 6 over 25, so that's 12 over 25 again, plus 3 times 4 over 25, that's 12 over 25 again, and then 4 times 3 over 25, that's 12 over 25. One more time. We can see there's 4 of them, so overall we've got 48 over 25. Okay, and if you do, out of curiosity, want to have that as a decimal, it's 1.92. Okay, so on average, we're going to get the number 1.92. What about the expected value of x squared? How do we do that? Let's have a look. So all we're going to do here, guys, is the same thing, but each x value is going to get squared before we multiply it by its probability. That's it. So 1 squared times 12 over 25, that's still 12 over 25, because we're doing 1 squared, 1, and then times it by 12 over 25. The probability does not get squared. 2 squared is 4, times it by 6, that's going to be 24 over 25. Next one, 3 squared is 9, times 4, that's 36. And then it's over 25. And then finally, 4 squared is 16, times 3, that's 48 over 25, okay? And again, just looking at my notes because, to save time and whatnot, that ends up being a fraction that simplifies to 24 over 5, of course, which is 4.8. 4.8. Okay, so 24 over 5 is what all of this simplifies to. You get 4.8. Okay, so that means that the second moment, the expected value of x squared, is the number 4.8. Now, what if you wanted to find an expression for, I don't know, the expected value of x to the power of n? Okay, what about that? Well, we can do it. So all we're going to do here is we're going to raise each of the values to the power of n before multiplying it. So 1 to the n is just 1 times 12 over 25. So that's just still 12 over 25. Then we're going to do 2 to the n times 6 over 25. So I'm going to write that as 6 over 25 times 2 to the n. The next one, we're doing 3 to the n times 4 over 25. So 4 over 25 times 3 to the n. And finally, we're going to be doing 3 over 25 times 4 to the power of n. This is an expression for the nth moment, or the nth order moment, the expected value of the random variable to the power of n, okay? Now, as an example, that means, using that formula, if you wanted to work out the expected value of x to the 4, you could try it yourself. You would just let n be the number 4, and it would end up giving you the number 48. Just as an example, I did that earlier, I did that working out earlier. That's how this works. Okay guys, last example question in this one. I do apologize for some of this maybe being a little bit illegible. This is my chalk, it is running low. I might have to change to blue in a second, but a random variable x has the probability distribution there. So just to read it to make sure there's no ambiguities, x is -2, -1, 1 and 2. And the probability of the random variable x taking each of these small values of x is 0.1, a, b, and c. The question is, given that the expected value of x is 0.3 and the expected value of x squared is 1.9, find a, b, and c. So this is an interesting question. Now, first of all, we can plug and play pretty much with these two, right? So first of all, let's start with the expected value of x. So how are we going to work that out? Again, we simply multiply the columns and add each up, okay? So we can say that 0.3 is equal to -2 times 0.1, so minus 0.2, minus a plus b plus 2c. That's one equation. Then we can do the same thing with the expected value of x squared. So we're just going to square each value of x. Remember, when you square a negative number, it becomes positive. So new equation, 1.9 is equal to 4 times 0.1, so 0.4, plus 1, because -1 squared is plus 1 times a, so plus a plus b plus 4c. Okay, now you might say, okay, cool, we've got two equations, but we have three unknowns. How are we going to get A, B, and C? Because there's not enough information. Well, this isn't something that I've said yet, but you might know that because this is a probability distribution, all of these probabilities have to add up to the number 1. That's going to give us our third equation, okay? And this is a very common exam style question, whether you're doing A levels, whether you're doing the IB, any other qualification, very, very common thing. So we can say that 0.1 plus A plus B plus C equals 1. This gives us three equations. Now, I'm not going to go through solving the simultaneous equations because it's a bit long and time consuming. Leave a comment if you want me to just, make a little unlisted video of it, but I don't think that's too much of an issue. I think simultaneous equations is a different topic, it's fine. If you solve these simultaneous equations, and again, please do leave a comment if you want me to, explain it in the description or something like that, but I'm just going to tell you, if you solve these simultaneous equations, you should get A is 0.3, you should get B is 0.4, and C is 0.2, okay? So it's just a case of solving a triple simultaneous equation. You can use elimination, substitution, or a bit of both to do that, and you should get these answers, okay? Otherwise, the video would take another 5-10 minutes because it's a little bit long. But that's everything I've got for you today. Stay tuned for the next video because the next one is going to be really, really interesting. It's about the St. Petersburg paradox. So please do stay tuned for that, coming soon, and I'll see you in the next one. Cheers.